Far beyond the familiar planets where the sun's light fades to a mere glimmer, a realm of profound darkness stretches for billions of kilometers, an almost unimaginable distance from our warm, inner solar system. This is a place where temperatures plummet to near absolute zero. The outer solar system, a frontier of icy bodies and faint light. Here, Neptune, a giant of ice and gas, marks the last bright outpost, a sentinel guarding the gateway to the unknown. And beyond it lies the Kuiper Belt, a vast and mysterious region, a scattered disk of icy worlds, remnants from the solar system's formation, like cosmic puzzle pieces scattered across an endless table. For centuries, armed with telescopes and mathematical models, we thought our solar system was fully mapped, its secrets laid bare. But the universe is rarely that simple, and nature often holds surprises that defy our expectations. Subtle clues in the movements of distant objects, tiny deviations from predicted paths, suggest our map may be incomplete, that something unseen is tugging at these icy bodies. Imagine standing on the shore of a vast, dark ocean, the waves crashing gently at your feet, seeing only the ripples hinting at something massive beneath, a hidden leviathan stirring in the depths. Astronomers are seeing those ripples in space, analyzing the subtle movements of celestial objects, whispers from the dark, faint signals that speak of an unseen presence, hinting at a hidden world, a massive planet lurking in the outer reaches of our solar system. The idea of a hidden planet is woven into the history of astronomy. The quest to find what lies beyond the known has always driven us forward. Neptune itself was predicted before it was seen, its existence inferred from irregularities in Uranus's orbit, thanks to a gravitational anomaly, a subtle tug that betrayed its presence. Now, history may be repeating itself with similar anomalies suggesting the existence of another, even more distant world, but on a grander scale, with a planet far larger and more remote than Neptune. The clues are subtle, the object elusive, hidden in the vastness of space. A world perhaps 10 times the mass of Earth. A super-Earth or mini-Neptune residing in the distant shadows, shaping the solar system from the shadows, its gravity influencing the orbits of smaller objects in the Kuiper Belt. This search pushes the limits of technology and human curiosity, requiring us to develop new tools and techniques to probe the depths of space. We peer into the black, using the most powerful telescopes on Earth and in space, seeking the faintest glimmer of reflected sunlight, a needle in a cosmic haystack. From a world that may take 10,000 years to orbit the sun, a truly alien and distant place. The challenge is profound, demanding ingenuity and perseverance in the face of immense distances and faint signals, but the possibility of a 9th major planet is one of science's most thrilling quests, a chance to rewrite our understanding of the solar system. Even our own solar system, the place we call home, remains a place of wonder and mystery, full of surprises waiting to be discovered. The hunt for Planet 9 is a reminder that exploration is never truly over. The universe still holds secrets, waiting to be uncovered by those who dare to look. Even in our cosmic backyard, there are frontiers to explore and mysteries to solve. The darkness beyond Neptune, once thought to be empty and desolate, may yet reveal a new world, a testament to the vastness and complexity of our solar system. And so, armed with curiosity and cutting-edge technology, the search begins anew. The story of Planet 9 starts with a puzzle strange patterns in the orbits of distant icy worlds called trans-Neptunian objects, or TNOs. These small bodies, drifting in the Kuiper Belt, should have random orbits, scattered by the gravity of known planets. But astronomers noticed something odd. A select group of these objects had orbits all tilted and pointed in the same direction. The odds of this happening by chance are minuscule. It was as if an unseen hand was guiding them, a cosmic anomaly. Neptune's gravity couldn't explain this alignment. Something bigger and farther away seemed to be at work. This clustering was the first clue, a breadcrumb leading to a bold new hypothesis. The universe was telling us look deeper. These tiny worlds acted as signposts, pointing toward a hidden gravitational source. The hunt for that source, a possible giant planet, was about to begin. The mystery of the outer solar system had just deepened, and astronomers were ready to follow the trail. Every mystery, especially those written in the language of the cosmos, needs detectives. For the enigma of Planet 9, the sleuths were a pair of brilliant minds from Caltech. They dedicated their time to unraveling the secrets hidden in the outer reaches of our solar system. Konstantin Batygin and Mike Brown, two names that would soon become synonymous with the hunt for a hidden world. Battigan, a theoretical astrophysicist, armed with complex equations and a mind for the unseen forces shaping the universe, and Brown, a planetary astronomer, a seasoned observer of the solar system's denizens, both known and unknown, formed the perfect team. Their skills and perspectives complemented each other, creating a formidable force in the face of a cosmic puzzle. Initially skeptical, as any good scientist should be when faced with extraordinary claims, they rigorously tested every alternative explanation, leaving no stone unturned in their quest to understand the strange behavior of objects in the outer solar system. For the strange orbital alignments, they scrutinized every possibility, from observational biases to the influence of known celestial bodies, but the evidence, like breadcrumbs in a cosmic forest, kept pointing to one inescapable conclusion: a massive unseen planet was shaping these orbits. A hidden giant lurking in the darkness, exerting its gravitational influence on the distant corners of our solar system. In 2016, after years of meticulous research and painstaking analysis, they published a groundbreaking paper, a bold declaration that challenged our understanding of the solar system, proposing a ninth major planet, a new member of our planetary family, 5 to 10 times Earth's mass, a true heavyweight compared to our own world, on a vast, elongated orbit. A journey so long that it takes thousands of years to complete a single revolution around the sun. Their computer simulations showed with compelling clarity that adding such a planet naturally produced, as if by design, the observed clustering. The peculiar alignment of distant objects that had puzzled astronomers for years. The planet's gravity acted as a cosmic shepherd, a celestial force guiding the movements of its flock, herding smaller bodies into alignment, a gravitational dance orchestrated by an unseen hand. The theory also explained other oddities, those lingering questions that had no satisfactory answers, like objects with orbits nearly perpendicular to the solar system. A bizarre configuration that suddenly made sense in the context of Planet Nine's existence. Their hypothesis was elegant, powerful, and testable, a trifecta of scientific virtue. If Planet Nine exists, it can be found. The challenge was immense, but the potential reward was even greater. The search for this hidden world became a global quest. Astronomers around the world joined the hunt, eager to be part of this historic endeavor. The next step was clear: find the planet itself, to capture its faint light and confirm its existence beyond any doubt. The stage was set for one of astronomy's greatest hunts, a search that would push the limits of our technology and our understanding of the cosmos. The chase was on, the race to find Planet Nine had begun. What would Planet Nine be like? If it exists, it's a cold, dark giant, unlike any world we know. With a mass 5 to 10 times Earth's, it would be a super-Earth or mini-Neptune, likely a gas giant with a thick icy atmosphere. Its orbit is immense, hundreds to over 1,000 times farther from the Sun than Earth. From its surface, the Sun would be just a bright star. A year could last up to 20,000 Earth years. Its distance makes it incredibly faint, a ghost in the darkness moving slowly against a backdrop of stars. Spotting it is one of astronomy's greatest challenges. If we could visit, we'd find a world of perpetual night and unimaginable cold. For now, it remains a phantom, its presence betrayed only by the dance of distant icy worlds. The tantalizing prediction of Planet Nine's existence ignited a global astronomical treasure hunt, spurring astronomers worldwide into action. The prospect of discovering a new major planet in our solar system is a driving force. Using powerful state-of-the-art telescopes like the Subaru telescope nestled atop Mauna Kea in Hawaii, and the Dark Energy Survey Telescope, strategically positioned high in the Chilean Andes, astronomers from across the globe meticulously began scanning the vast expanse of the night skies. They are looking for any sign of this elusive world. The search, however, isn't simple. It's a monumental challenge. The planet's predicted orbit is incredibly vast, spanning billions of miles, and its exact location remains stubbornly unknown. This makes the search area immense. To tackle this, telescopes repeatedly image large swaths of sky, capturing the light from countless stars and galaxies. They are looking for a faint object, a tiny speck of light, that moves ever so slightly against the fixed backdrop of distant stars. This movement is key to identifying a planet. Each night, these observations generate terabytes upon terabytes of data, a deluge of information. This is far too much data for human eyes and brains to analyze alone. It would take lifetimes. Therefore, sophisticated computer algorithms are employed to sift through the images automatically. These algorithms are specifically designed, searching for the telltale motion, the subtle shift in position, that would betray the presence of a distant planet. In this endeavor, the hunt is as much about cutting-edge data science as it is about traditional astronomy. Adding to the difficulty, Planet 9 could be hiding in a particularly dense star field, obscured by the sheer number of stars. This makes it even harder to spot, like searching for a needle in a cosmic haystack. Every potential candidate, every faint object flagged by the algorithms, must be meticulously checked and reobserved to rule out false positives. The process is painstaking, demanding immense patience and meticulous attention to detail, and progress is often slow. But the potential reward is immense. The discovery of a new major planet in our solar system would be a monumental achievement. And so, the search continues, night after night, with telescopes around the world tirelessly scanning the heavens. They are searching for a world that has so far remained hidden, a mysterious giant lurking in the outer reaches of our solar system. The sky holds its secrets tightly, guarding them jealously against prying eyes. But astronomers, driven by curiosity and the pursuit of knowledge, are determined to unlock them, no matter how long it takes. Finding Planet 9 is like searching for a single grain of dark sand on all the world's beaches at night with a weak torch. The search area is enormous and the planet's faintness is extreme. Its brightness depends on size, reflectivity, and distance, but at such a range it reflects almost no light. Astronomers are looking for something thousands of times fainter than Pluto. Its slow movement makes it nearly indistinguishable from distant stars. Automated algorithms can mistake it for noise. Confirming its motion takes months or years. The combination of vast area, faintness, and slow movement makes this one of astronomy's toughest challenges. The risk of failure is high, but the reward, discovering a new planet, is monumental. Every night astronomers refine their techniques, hoping for that one faint, moving point of light. The cosmic haystack is vast, but the searchers are relentless. The ghostly planet may yet reveal itself. Every bold idea faces scrutiny, and Planet 9 is no exception. Some astronomers argue the orbital clustering could be an illusion, an artifact of where and how we search for TNOs. Observational bias might make the pattern seem real when it's not. Others suggest the combined gravity of many small objects, not a single giant, could explain the alignments. The most direct argument, after years of searching, Planet 9 remains unseen. As more sky is covered, the possible hiding places shrink. If it's not found, doubt will grow. The absence of evidence isn't proof of absence, but the mystery endures. The outer solar system's secrets remain unsolved. The debate over Planet 9 highlights the beauty of science, a journey into the unknown full of surprises. The search has already led to new discoveries, dozens of trans-Neptunian objects, each a relic from the solar system's dawn. The Kuiper Belt is more complex and dynamic than we imagined. Some even propose exotic alternatives, like a primordial black hole instead of a planet. Whether or not Planet 9 exists, the quest has expanded our understanding and imagination. The solar system is still full of mysteries, waiting in the darkness. The search is about more than a planet. It's about our place in the cosmos. Curiosity drives us to keep looking beyond the next horizon. The story of Planet 9 reminds us we've only begun to explore the cosmic ocean. The idea of a hidden giant orbiting the sun is humbling, showing the limits of our perception. Discovery is a journey, not a destination. This quest embodies the spirit of exploration, curiosity, evidence, and relentless optimism. Even if Planet 9 isn't found, the search itself leads to new questions and insights. Science is about asking better questions, not just finding answers. The hunt has inspired astronomers and captured imaginations worldwide. Every night telescopes scan the heavens searching for a missing world. Whether we find it or not, the search is a testament to our endless curiosity. The universe's greatest wonders may still be hidden, waiting for us on the endless frontier.